Hi, we are going to discuss about the system design today. We know system design is a process of designing the architecture, components, interfaces for a system so that it meets the end user requirements. So, system design properties and features you can see here: scalability and reliability. How scalable the system is, how reliable is the system. When you are designing something, it is very important to consider this factor. At the same time, efficient resource management. Whenever we are building a system, we should make sure the efficient resource management should be there, right? And the system should be adaptable. In future, if business is going to change its needs, then system should also be evolved as per the business needs and requirement, right? By reducing long-term cost. So architectural understanding. So whenever we are designing a system, right? So we should have some architectural understanding, whether it is monolithic or microservice based. We should understand that. So now, so I want to discuss the basics for system design, and we are going to see uh, different uh, factors like scalability, databases in designing system, and consistency, availability, and we are going to see the load balancing concept also. How are we going to handle the load balancing? How whenever if there is a um, high load, I mean, business is getting peak load, then how we are going to handle that, how we are going to load that balance. Now we can use the load balancing concept to handle that scenario, to solve that problem. Latency, throughput, caching. We are also going to discuss latency is a very important factor, response time. So how much time it is going to take for processing a request. It is very important, and it should not be like more than 1 second or 2 seconds, right? Um, then it would be a problem. And we can also see how API gateway messaging queues, so they will be used in system design, how they are going to be designed. We have protocols, content delivery network, proxies, WebSockets. So I want to discuss about that. Testing, how we do the integration testing, CI/CD pipeline. We will have all this information. And security measures. How we are going to add SSL certificate, right? SSL, establish SSL security, authentication, authorization, database level, how we handle the database level backups and disaster recoveries. So we can study them under security measures. Most of the time, if system is very complex, we go for distributed system design. So that time, what are the key things we need to understand for the distributed system and distributed tracing? How communication is established in distributed system is also very important. Okay, so a low level design, there is a high level design and low level design. Generally, in high level design, we touch each and every component and how they are integrated related with the complete whole system. Low level design is a class level or entity level, so component level we actually design the things, right? For that we use UML, Unified Modeling Language, for creating a design. And whenever you are designing system, you always keep in mind the design patterns. Following design patterns is very important thing when if you want to build a very good architecture of a system. So we should have an idea about all the design patterns, the singleton design pattern, factory, abstract, builder, prototype, facade, pattern, strategy. So many patterns we regularly use them, right? Adapter pattern also. Um, if two different systems are there, we need an adapter to uh, make them to make them sync, right? We need an adapter. So many design patterns are there. So if we have a basic info about these informations, and we can build very good system. So let's go into this and see how we can explore each one. So as I told you, high level system design and low level system design, right? High level design. So before that, SDLC, software development life cycle. We all know that analyze, plan, maintain, implement, and develop. These methods are stages we follow in the SDLC software development. And you see here the low level design, as I told you, the big picture, big architecture is nothing but a high level design. Low level, detailed class level, module level design. And we have to mention the define the logic and data structure, and how request flows throughout the system. Low level design we have to explain. High level, we should define the components. What are all the components are involved in a particular system? Focus on scalability, performance rate. High level design. Let's say I need. I want to build a microservice application or monolithic. Let's take a monolithic application. Then I need a web UI, and I need a middleware. I need a database, right? Backend databases. So for that I can use Oracle database. For middleware I can use Java. Um, for front end I can use AngularJS or HTML. So what are all the components that are involved? It is a high level design. Low level design means how what classes we are building using a Java for implementing application. So let's say I'm going to build a controller, and controller to request goes to service layer to it goes to repository, data layer. So that is nothing but a low level design. Explaining the low level and things relate will come under the low level design. High level design is nothing but a big picture, high level picture. What are all the components integrated involved in the whole picture? So that is very important when we are going to define um, system, particular design system. And other thing is we need to understand what is functional, non-functional requirement. Functional requirements are nothing but what is the system is going to do. I mean, what actually system is going to perform the functionality. You take an example of any website. So you take a Google. It is a search engine. Its functionality is a user will search anything. It can search anything. It's one of these. It is its use case. Its functionality. That is one of the example. Okay. Also, non-functional requirement means how efficiently it can perform. We all know that whenever we search something, Google will immediately display the content for matching keyword, right? So how fast it is going to display it, it is going to display in a faster way. So its performance is very good. So performance is a non-functional requirement. So how the use case functional requirement and displaying some content for a matching keyword is a functional requirement. So under non-functional requirements we will have many things. You can see security, performance, usability, ease of use. Sometimes it is very important to build usability, I mean to build application with ease of use. If you are building a web application with a complex navigation and complex usage, it ultimately the user will get confused, and it will result into negative feedback and negative usage. So we should avoid that. Reliability and how efficient, how reliable is the system, how I mean the availability. Let's say if we have one server or two server, three, four, how many servers you have in the back end, you should decide. Whenever the load is very high, so you should have a capability, server capability to serve the request. Even if one, two servers failed, remaining two will help you to handle the load, right? So that way you can achieve the reliability every time. The clients or users should be able to use your application. If sometime application is going down and sometimes it is going up, then reliability is going to be affected. Then customers or users will lose the interest on it, right? So the scalability, if the business is growing, then application should be able to scaled, and you should be able to maintain it also. So these are all some key factors in under non-functional requirement. Functional means the behavior, what is its use case, its behavior, what are the features it is going to provide. All these things will come under functional requirement. Okay, and uh, generally we should be aware of some architecture styles. So you can see here there are majorly these architecture styles like monolithic architecture, microservices architecture, or event driven architecture, serverless architecture. Okay, these are the main architectures. I want to explain these things. So what is monolithic architecture? Let's discuss here what is the monolithic architecture. You can see here, um, we'll have some single application. Okay, it will have different modules, and whenever request is coming from multiple clients, it will come to that single application will process the request, and it will get the data from rdbms database. It will render the response back to clients. So we can see the load balancer there. We will discuss about that load balancer later. For now, keep it in mind. The load balancer generally used to balance the load. Let's say we are getting request from three clients, and it should balance it. I mean, it should navigate. It should navigate few requests to another one server, and a few requests for another server. So basically, in monolithic application, we always will have one application, one module. Everything will be created in a single application, all the modules. But there is a problem with the monolithic application. You can see here I am going to build a e-commerce application, and this e-commerce application is going to have a shopping UI, catalog service, discount service, orders. Many services are there. But in case tomorrow if I want to add more services, the application is going to is going to get complicated, right? It will become very complex. It will become complex for maintaining it. It will become complex for handling it in case if any issues, errors, exceptions occurs. So fixing, supporting also will become an issue. So these are all the issues. I mean, if the load is going to be very high, and this single application may also may not be able to handle that load. Sometimes single point of failure also can happen. Let's say if any issue happen in any of the one modules, shop UI, some error occurred in shop UI, and all the application will not work. It may not work, right? Because everything is here dependent on with each other. So this there are some problems with the monolithic application. If your requirement is very simple and straightforward, if your application is not very complex, it is a lightweight application, then you can go for a monolithic system based architecture. but your requirement is very complex and you are going to have multiple systems components required to build a complete system, then monolithic architecture is not as suitable. Then you should go for a microservices architecture. So here you can see here the microservices architecture. What are we having? See here, modules are divided into separate microservices. And each service is having its own database, right? So that way we are splitting and we are actually div- uh, creating a independency here. So every service will handle a separate single responsibility, right? Separate single responsibility. You can see here account service, inventory service, shipping service. All three are different service. Whenever request is coming, okay, request goes to the particular service, and another service will um, so it will be invoked and it will get the respective data from there and then it will process it. So what is the use of this microservices architecture? Because we are separating out the services. If any of the service failed, the other modules of service will not get affected, right? And maintenance is also would be very simple. Separate teams will handle the separate service. Let's say inventory department will handle inventory service, account service section will handle the account service. So that way the complex application can be simplified. The maintenance would become very easy, right? That is why we can actually we can go for microservices architecture. Other thing is event driven architecture. Okay. uh, so I want to tell what is event driven architecture first. So here you can see in a particular event, in a particular event source, whenever some event is happened and then we will publish that event. There will be event broker and this event broker we will publish those events to event broker, and from the event broker different subscribers will consume that events. So this is a basic, it's just like a sending a message to event broker, and from there whoever is subscribed to that event broker, the corresponding message will be consumed by the subscriber. Okay, this is nothing but pops up publish and subscriber approach. um, so we'll take a e-commerce site here. Okay, so there is a they want to book an order, new order is coming. Then it will post a message to event um, topic. Let's say it will go to event router, and from there you can see event. So you can see here it is router ingests filters and pushes the events to appropriate consumer. So event router, it nothing but it's a list of messaging queues, maybe messaging queues. It will push these messages to the respective consumer, right? Consumer will consume the respective message. So even generally what I'm telling, it is like a publisher will publish some message based on event and subscriber will subscribe that. Event broker is acting like a central hub. Event broker, you see, or event bus facilitate communication between various components handling a event distribution. So yeah, you always think this in like a post office kind of style. Somebody will post some information through post and that post will reach to the corresponding destination address. In the same way, whenever some event happened in a particular software component, it will publish that message into a queue, a topic. From there, a corresponding consumer will read the data and it will process. They'll process the data. Okay. Other architecture is serverless architecture. Okay, this is a new style of coding. It is coming recently. Um, if you look at the cloud, all the cloud providers, they are introducing this serverless architecture. Okay, in serverless architecture, what we are doing, we will just write the code, right? We'll write the simple function. If you take AWS Lambda, we'll write the simple code, simple function. We don't bother about where we are deploying, what are the servers. We don't need to bother about it. We simply write the function and it will get deployed by cloud provider itself. So this is called serverless approach. Serverless approach means you don't need to worry about how you are going to deploy your code. You just write a piece of code and cloud itself will automatically take care of deploying your code and running your code, right? So that way you can only focus on the core logic instead of bothering about servers, infrastructure and everything. So those are the main four architectures. Okay, next thing is horizontal scaling and vertical scaling, scalability, right? So what we have to do here, horizontal scaling means, okay, let's see. Horizontal scaling is nothing but when you want to scale uh, uh, performance, you have to increase the RAM capacity, CPU capacity. That is vertical scaling. So vertical scaling means if whenever your load, your need or your requirement is very huge and you want to process multiple requests or something, that time your existing server or computer may not support handling the request. Then what you usually do, you will increase the CPU, you increase the RAM size, hard disk, you will increase the hardware basically. So this is called vertical scaling. But here is the problem. Vertical scaling, you cannot we can do it, but the problem is it is cost efficient, right? And it's time consuming process. It is not very dynamic in nature. Horizontal scaling is nothing but so you will just add another server instead of increasing a CPU load or other parts. Okay, and this is horizontal scaling. Always remember, this is horizontal scaling. uh, it is a complex architecture. You need to have a load balancer, distributed databases. You need to maintain it, horizontal scaling. Both are having its uses and problems. Depending on the requirement, you can choose the respective architecture. Okay, that is about horizontal scaling and vertical scaling. But why do I need to scale application? That scalability, why do I need to scale the application? The thing is, let me tell you one thing. Why do you need to scale a particular application is whenever you meet increased user load or traffic is there, your existing infrastructure may not be able to handle that load or server response, right? Then that time it may lead to uh, um, your system may get overload and it will get overloaded and it may not work properly due to the heavy load. So that will become a failure, that will bring the loss to the revenue to the business. So the scaling is very important. Tomorrow, today you have built your servers and application based on 1,000 users, but tomorrow or in future you may get 1 lakh users. Your business uh, may be expanded, and that time you need to uh, provide dynamic scaling, right? So that is where the scaling is very important. So whenever you are building a system, in a system design, you always think in such a way that your existing system should be flexible and should be able to support the scalable, should support both vertical and horizontal. Depends on the requirement, you can do that. Okay, and other thing is deciding database in while designing a system. So we have majorly two kinds of databases, right? One is SQL database, other thing is a NoSQL database. So we all know the SQL databases are relational databases, and both will have we can store the data in the rows and column purpose, and relational database it supports asset properties, right? Atomicity, consistency, isolation, durability. So most of the banking and financial applications they use Oracle database, since they want to follow the asset properties and all, right? So they need a consistency, they want durability, right? All this atomic, I mean, whenever they are doing some transactions, all the transactions should be stored without any break in the middle, right? So it is very important. That is why financial systems and banking, in inventory management system, most of the things, their domains, and they will use these SQL databases. But what about NoSQL? You take uh, any semi-structured data. Um, Generally, structured data is nothing but storing data in the form of rows and columns. Semi-structure means we may have unstructured data also. Semi-structure the data which is not in a structured format. You take a Facebook, people will post their messages in Facebook. They may post their name, address, and mobile number. They are not a structure, right? I mean, our name is a single field, the mobile number is integer, address may can have 3 or 4 fields. So all when you combine all these, there are it is unstructured. It is not a similar data. We cannot store it like into a single column, like. Right, I want to store that as an object into a database. So here, whenever we want to store a data, that too unstructured or semi-structured data. Unstructured means you take any video or audio files, or semi-structured Excel files, Word files. You want to store the data, or you want to store some blog information. In Twitter also, people will post tweets, many things. So we cannot store this kind of data into relational database. So that is why we need NoSQL database. There are so many NoSQL databases are there in the market, but majorly most of the time we use MongoDB and Cassandra and GraphQL, and so many databases are there. We can use them. So that is why we choosing a database as per the requirement is very important. But the problem with the NoSQL databases, they do not follow ACID properties. I mean, they follow the CAP theorem. Um, okay, they don't follow the ACID properties. That is because it is a NoSQL data. But the major concern for choosing the NoSQL database is performance, speed. So how fast you can store an object, how fast you can get an object, right? How fast you can store a JSON object, how fast you can get an object. So speed is the parameter here, speed is the factor here. You don't need to bother about how I am going to normalize my data, how I am going to store my data, and is it following any is it properties or not. You don't need to bother about when you are dealing with NoSQL. If that is your requirement, then you go for NoSQL, otherwise you go for SQL database. So I hope you understood what is a SQL, NoSQL. I don't want to discuss about all these I think so. You can see here database replication system design. Definitely, we will replicate the databases in the system design whenever we are increasing multiple servers. And SQL query optimization, denormalization, database. Okay, these are all the sub concepts. So majorly, you don't need to know about all these things, but think in a mind when you are going to design a system. You need to that shows whether it is SQL NoSQL. Let's go into file or database file system. Second point, I want to show you that one as well. So, what is a file? What is a database? A file is nothing but a storage where we um, write our content and store that particular file in a particular location, right? It's not like a database. So why do I need a file? Because sometimes on the website or sometimes in our system or application, we may need to process multiple files. We may need to download multiple files. Then, so we may need to show some static files. Then I should store these files in file-based storage system. Generally, we will use we will mount a particular NAT location, and we will use that NAT location as a file storage for our files, right? We also can store some files in cache, and we can also access those files if they are static files and all. So this will come under the file system. Okay, and that is the other thing. And one more thing here, database replication system. Okay, let me go through these concepts as well. I'll go in a high level. Why do I need? Okay, there is a diagram. Okay, there is no diagram, but I'll explain importance of. Okay, by distance, I'll tell you scalability, reliability, availability. Why do I need to replicate the database? These three factors are important: scalability, reliability, availability. See, by distributing the data across multiple servers, organization can guarantee that it will remain accessible even in case of server failure. We should distribute the data. We should have a backup of database, right? Some let's say some cases database goes down, and we should have a backup database also. And sometimes we should also distribute data. Some people may store some customer data. Some people will store some transaction data in another database. Some people, sometimes we store likelihood data in some other database. So it's all depends on the requirement. So database scalability, replicating the database is also required. Whenever you are creating microservices architecture, you will definitely replicate it. And in case of disaster recovery also, as I told you. And if you need high availability guaranteed by the replication, sometimes you may get multiple requests. So you need to have, if you are having a single one or two databases, it would be a problem. So if you are having many databases, availability will be very high, and fault tolerance also will be there. If any server failed, another database will serve the request. Scalability and all, and the latency also very good. So I mean, it will reduce the latency. There won't be high response time. So in a very less time also, you will get a result. So that is about um, database replication and normalization process. Normalization nothing but you can have you can store everything in one table, but why we divide the table into multiple tables? Normalization, we should normalize. I mean, that way uh, we can simplify, we can segregate the data category, and also we can establish a relationship using foreign key, and also we can get the data, right? So normalization is required to improve the performance. If everything is going to get stored in single database, it will result in millions of records, and while fetching the data, it is also a problem for us. So we should not do that. So that's why we should store data, and by segregating it, address data, address information should be stored in address table. Customer information should be stored in customer table. Okay, and transaction data should be stored in transaction table. So you cannot store everything in a single table. You should normalize the table. You should normalize your database. You should normalize your schema. So it is very important. A denormalization database, as I told you, for NoSQL databases, you don't need to normalize the data. You can store everything in a single collection, right? Why do you need? Because we are not bothering about asset properties here. Our In case of NoSQL databases, speed is the matter. Speed is the factor. So how fast I can store an object, or how fast I can get an object. It's like a map, right? Hash map kind of scenario. Store a value with a key by giving some address and get that value whenever we want to require it. Okay, Redis database is generally used for cache purpose. Generally, you don't need to know about it. So there are so many databases. HCAche manager we can implement, or any database. So many third-party databases are available there for catching purpose. Catching means I hope you are aware of it. Okay, let me explain what is catching also. So you can see here, whenever client is going to send a request, first the request goes to API, and from there it will go to database generally. So for every time, if you want to do that, it will take time, right? It will every time if same request is coming, and it has to go to the DB to get the data. We can do it, but it will take time. So to reduce the latency time, right, we will introduce another database in the middle between API and actual database. So what it will do, for the first time the request goes to actual database, and it will store the data into Redis database in the middle as a cache. So next time whenever request is coming, it won't go to the actual database, rather it will go to Redis database. It will get the data from there. So here, what is cache hit, cache miss means, when you send a request, if the data is available in a Redis database cache, then we call it as a cache hit. In case if the database is not available in cache, then we call it a cache miss. Then the request goes to database layer. So we need to understand this is a kind of catching purpose. And we discussed about the availability in system design. I told you how available is the system. How to achieve availability. Okay, we will discuss. Um, Generally availability means um, the guarantee of a system. Also guarantee of, we are giving a guarantee to our system that our system will work anytime without any failure. That means 99.9% availability will be there. People will say our system will be available 99.9%. Only few cases it will fail, it will not work. So whenever the availability is very high, then likelihood of customers using that customer will be very high. So the higher is the availability, the higher is the likelihood, and people will prefer to use that kind of system. So designing the availability in case of system design is also the key factor and key thing. So what is the availability here? Why is availability important system? User experience, because you should get the positive feedback, right? Whenever people are visiting some site or your application, sometimes it is running, sometimes it is not running. What does it mean? Users will get a negative feedback, so it is not good. So SLAs means service level agreement. We know that many businesses use SLAs to bind themselves to certain availability goals. So they will define some SLAs. So SLA, they'll sign the SLA, service layer agreement, and they will specify the availability. Okay, availability is also one of the factor they will specify in the service level agreement also. along with the response times, latency, availability. They'll mention all these things, service level agreement, when they are having a contract with the business. Okay, generally, how do we achieve availability? We should have a redundant servers, and having cloned servers is a key thing. And we also have a load balancer. A failover mechanism is also important. Let's say once if one system fail, redundant system can operate. Or disaster recovery, but taking a backup is also important. In case something is destroyed, or some server is not working, then immediately redirecting the load to another servers. Meanwhile, repairing the actual server and getting the data back from the backup server is also important. Monitoring, alerting, performance optimization, scalability. Okay, performance optimization. All these are the factors, right? We need to have all these things. Okay, next, how to achieve high availability. I told you all these factors. I mean, redundant servers and having a backup. So there are all these factors. Okay, let me click. Let me see if any other things are there and discuss. Okay, high availability. See, minimize the downtime. What is the downtime? Let's say your application went down. So then, what is the recovery time? So how much time you take to repair it, and how much time you will take it to get the system online? So that is called um, recovery time. Downtime is how much time the system is not working. You can say high availability in the system, it is operational, minimizing the downtime. So we should always minimize the downtime. That means if your system is not up and online for 1 hour, then it is a big loss, right? So that is why you should always reduce the downtime. And reliability, you should ensure the reliability. You should enhance the user experience, support critical function, protect against disaster. All these things will come under the availability section. Okay, so consistent, how consistent is the system? Sometimes if you are showing one set of data, for another time if you are showing wrong data, then there is no inconsistency. So systems always should be consistent. Should work in a constant way. So that is the consistency part here. And okay, so far we discussed about here, and we will discuss the remaining sections later. Thank you for listening. Thank you all.